Welcome to the second lesson in chapter 8.4, and this will focus on graphing logarithmic functions, identifying asymptotes, and also identifying domain and range for a logarithmic function. When we look at the graph of a logarithm, so the general parent function, f of x equals log of x, and we're going to deal mostly in base 10 and base e for logarithms, just because that's what our calculator will do. If you plug this into a graphing calculator, you get a graph that looks like this. And we'll notice when we go to our table of values that when we try to do log of 0 or log of -1, it just doesn't work. That's not a part of the numbers that we can take the logarithm of. So there's no values in the table on our graphing calculator. But if we plot a few points here, we can see the shape that the logarithmic function begins to take. And we'll notice that instead of having a horizontal asymptote like we're used to with an exponential function, we actually have now a vertical asymptote. And in this case, we have a vertical asymptote that has the equation x equals 0. It's right on that y-axis, and the equation of that y-axis is x equals 0. We'll also notice that our domain and range are a little bit different. If we look at the graph, we'll notice that all of my x values are to the right of that asymptote. They are all greater than that 0 value. There are no x values on the left side of the graph, no negative x values over here. So our domain, we're going to say x is greater than 0 for this particular graph. The range deals with the up and down on my graph. So for example, my logarithmic function will continue up and up and up forever and ever and ever. It also will continue down forever and ever in the negative direction. So we're going to find that our range is going to be all real numbers. We can use that little all real numbers symbol if we want to. So this is what a logarithmic function it looks like. It has a vertical asymptote. It has a domain of x is greater than that vertical asymptote, and our range for a general logarithmic function will be all real numbers. Logarithms also have a form using h and k, and we can see we're used to seeing this with exponential functions and other functions we've seen. X minus h will be my vertical asymptote. And we will always remember that if I have an h value in there, when I go to pull it out, I should always pull out the opposite of what I see. So for example, if I have log of x minus 3, h in this case will equal positive 3. And then my k value is whatever's added on the outside. That just is what it is. So we will have a vertical asymptote at x equals h, and then my domain for logarithmic functions will always be x is greater than h, and then my range will be all real numbers, or we can use that r sign. So now that we've seen what h and k do in a logarithmic function, let's go ahead and graph an actual example. We're going to do a natural logarithm, which, remember, natural logarithm is base e, and there's a button on our calculator. And so what we can do is we can create a table of values. I've done this using my graphing calculator, and so these are the points that I will eventually plot. But first, before we even do that, let's identify these three parts: my vertical asymptote, my domain, and my range. H and k in this case are 1 and 2. I know that it's a positive 1. I'm going to pull out the opposite of what I see, positive 1. So if h is 1, then my vertical asymptote is x equals 1. My domain is x is greater than 1. It's always that h value. I'm not actually going to do anything with k in this case. And then my range is all real numbers. Now I'm ready to plot some points. The first thing I'm going to do is make a sketch and plot my vertical asymptote. So I will go and find where x is 1 and create a vertical line for my asymptote. Then I can plot my points and sketch my curve. And this is a rough sketch of what this function should look like. And to get my table of values, if I don't have a graphing calculator, all I have to do is pick a couple of values. And if you'll notice in that table, since my domain is x is greater than or equal, or sorry, greater than 1, this number here tells me where in my table I need to start. I need to pick x values greater than 1, which is why 2 is really where I started to get values. So that's something to think about if I'm doing this by hand. Let's just do one last example together. The first thing I'll do is I'll identify h and k. H is always inside the parentheses with x, and it's always the opposite of what I see. So here h is -2, and technically k here is 0, but we really don't care about k right now. K doesn't do anything for us when we're trying to graph. So now I'm going to identify my vertical asymptote, x equals -2, and my domain, x is greater than -2, and my range, all real numbers. Now I'm going to plot my vertical asymptote at -2. And now I can plot some points. And again, I've plugged them into my graphing calculator, or you can do them by hand. And remember, if your domain says x is greater than or equal to -2, then you need to pick the next number after that. And in this case, it would be -1. Any values less than -2 will give you an invalid answer. It'll say non-real answer. So we'll plot these points here. And I've done my best to plot my points as best I can. And now I'll sketch my logarithm curve right through these points. Goes up, and then remember, it'll approach this asymptote, never to touch and never to cross. And this is how we graph a logarithmic function. The very last thing we want to be able to do is we want to be able to look at a graph without an equation of anything and identify the domain and the range. And the first thing we can do is we can say what the range is for both functions. The range will always be all real numbers. And I know that because when I look at each of these graphs, it will forever go up and forever go down. That's how I know that the range is all real numbers, all possible values of y. For my domain, however, that's when I want to identify where that asymptote is. So in the first one, the asymptote is right here at x equals 0. So my domain is that x is greater than 0 because everything is to the right of that asymptote. The same process is what I'm going to use for the second. It's right here, x equals -5 is my asymptote, that dashed red line. So my domain is everything bigger than -5 because it starts at that line and goes to the right. It's all those numbers that are bigger than -5. And that's how we identify the domain and the range given a graph.
Made with DoodleCast Pro.